Transparency as a general topic, which draws on all of these underlying technologies, and also some new work in generative AI, generative modeling, which poses some unique challenges with respect to AI documentation. We are active in the external community, of course. As a research organization, we publish fairly extensively, and I'll point you at a few of the papers, but there are many more linked to the websites that I'll point you at. But we're also active contributors to the Linux Foundation. So far we have contributed 3 of our trusted 360 AI toolboxes: first fairness, then explainability, and most recently adversarial robustness. And there may be more to come. It's hard to know for sure. So the underlying toolkits are available directly through the Linux Foundation as well. Of course, we're part of a much larger organization, and IBM is active in providing tooling for AI model creation, testing, assurance, monitoring, and so on. And I'll provide one pointer near the very end of the talk with regards to that. We are active most recently in the era of COVID on using some of these technologies for social good. So creating systems for discovery related to molecules and the like. And we're very active as well in the larger AI ecosystem in the policy realm. So IBM has its own AI ethics board, which is probably exemplary of what many organizations will eventually create for their own assurance with regards to AI. The Partnership on AI, PAI, is a multi-industry and university consortium. We are active on the board of that. We were part of the EU Commission on high-level expert group on AI and helped formulate the EU guidelines, which are now published, NIST in the United States, and so on. So this is the larger space in which we play. A different way of thinking about what we do is to look at trust as a multifaceted thing, where at least these 8 elements are prominent. Performance, of course, which you can think of primarily as accuracy. And of course, accuracy itself is multidimensional and very dependent on context and model type and so on and so forth. Fairness and bias, explainability, uncertainty, how you can quantify that and deal with it. Adversarial robustness, privacy, which is closely related in some respects to adversarial robustness, data quality itself, since so much of the performance and other attributes of an AI system are derived from the data itself. Focusing on data quality is a key aspect of forming trustworthy systems. And then testing, various ways of probing an AI system to see if it is performing as desired. So I've given some hints. Here are some pointers. All of these URLs, well, what happened? There we go. Our first 3 toolkits surfaced also, in addition to the Linux Foundation. There are websites available for exploring the underlying toolkit, seeing demos of its capabilities, reading tutorials, having the links to videos and other presentations and upcoming events. And so it's all consolidated in these 3 websites. The first, AIF 360, you can probably find it from just that, but the full URL is not very long, aif360.mybluemix.net. And all of the URLs have the same form. So there's fairness and bias. There's explainability, AIX360. There's adversarial robustness, which is ART 360. There's an internal, currently only internal tool on data quality called DART. Just today, again, we're releasing UQ 360, which is uncertainty quantification, and another internal tool, Verify AI. So these are just a sample of some of the tools. Diving in a little more deeply to the first three. So AIF 360, and there's the URL. So if you didn't write it down, no worries, there it is. So you can see it's fairly extensive. I mean, we have on the order of 70 and growing metrics for fairness. And if you thought fairness was complicated, your intuitions are correct. There are lots of ways of assessing it algorithmically, and these are assembled for that purpose in this website. It is also possible, again, algorithmically to mitigate bias at various stages of the AI lifecycle, starting with data and ending up with post prediction adjustment. And 10 of these mitigators are included as code on the site. There's an interactive demo with 3 data sets, 5 of those bias metrics and 4 mitigators. And it steps you through at least a way of thinking about using the underlying toolkit. And then again, as I mentioned, there are a number of industry tutorials and notebooks. The industry tutorials try to situate this within a context. So that's AIF 360, and that was our first one, released about 2 years ago now, I think. Followed by Explainability 360, again, a number of algorithms for generating explanations. Another interactive demo. This demo is somewhat different in style, because when you think about explainability, you're definitely bringing the human factor in, right? I mean, you're explaining it to someone for some purpose. And so what this demo attempts to give you a sense of is 3 different persona for whom you might be preparing an explanation of a prediction, say. So in this case, this is a loan scenario and 3 different persona: the data scientist, who again is probably trying to debug behavior of a model; a loan officer who's simply trying to get a richer understanding of the space around, say, a rejected loan application, to see similar loan applicants and try to understand the difference. And then a bank customer, an individual customer who's really only interested in 2 things, or 3 things, I guess, really. Was the loan approved or rejected? If it was rejected, why? And if so, what might they do to improve their chances of receiving a loan? So that's what that demo attempts to do, again, drawing on the underlying toolkit. Adversarial robustness is our latest of the 360, well, not counting uncertainty quantification, which is new today. And again, there's a number of demos and underlying code for various aspects of detecting weaknesses against attack, and so on. Finally, AIFS, AI Fact Sheets 360, is what I'll be spending a little bit more time on, because in fact, I'm going to be shifting now to talk about fact sheets, which is our notion of how to document AI models and services. The website itself continues to grow in richness. There are multiple fact sheets shown. There's a brief description and a pointer to a paper on what we call our 7-step methodology for creating useful fact sheets. There's the beginning of a description of how transparency via fact sheets plays in an AI governance world, where you're actually providing some control over how AI is developed, tested, deployed, monitored, and so on. And like the other sites, there are links to papers, videos, and so on. So let's turn our attention now to fact sheets. And I want to make a key distinction, which is useful, I think, for the rest of this talk. So on the one hand, we have AI transparency. And this is really about, for example, giving a consumer a better understanding of an AI model or service. And a consumer is a general term here. I don't necessarily mean an end user. It could be anyone along the AI development life cycle or outside regulators and so on. So transparency provides information. Governance, on the other hand, controls how things are done. And it builds on a foundation of transparency, okay? So we've been at this for a while. Our first paper was actually published, well, it was made available on the outside before the IBM Journal of Research and Development published the paper in 2019. But this was the first of our work on fact sheets. You can see it's a somewhat cumbersome title, Increasing Trust in AI Services Through Suppliers' Declarations of Conformity, which is, again, a bit of a mouthful, but it's sort of an industry term in general for suppliers to indicate that what they are providing is, conforms to some set of requirements, specifications, and the like. So that's where that came from. But we just call them fact sheets. Again, I'll be saying quite a bit more about that. Now, there's inspiration elsewhere for these sorts of fact sheets, of course. The very popular nutrition label with which we are often compared, although quite incorrectly, as you'll see. There are energy compliance labels, at least in the United States. There's something called Energy Star, which gives the consumer some assurance that whatever they're buying, generally a large appliance, it is reasonably conservative when it comes to energy consumption, and so on. So there are lots of examples of these. Of course, if you're familiar with the semiconductor world, there are what you could call fact sheets or spec sheets for component parts and so on and so forth. So there's nothing new about the idea, but applying it to AI is somewhat new. Of course, we're not the only people in this space. There's the notion of model cards and data sheets and so on and so forth. So there are several folks working in this same space. We take a somewhat, at least with respect to some of the work that we do, what I'll call a user-centered approach, because none of this is going to work well if all you have is technology that people cannot use to create facts, to consume facts in a meaningful way, and so on. So we've spent a fair bit of time trying to understand the difficulties and challenges of creating these fact sheets, and there are surprising problems, which I'll get to in a minute. And then in order to mitigate some of those problems, we have created, again, a methodology, which I'll take you through at about the halfway point in this talk, for creating AI fact sheets with a particular focus on what we call fact sheet templates. And I'll tell you what those are and why they're important. So that's on the one hand, we've developed a methodology. On the other, we've also defined an API, because we think that for this to actually work and scale, to the extent that it is possible to automatically generate and capture facts during an AI model development, deployment, and so on, you should. And an API and an underlying repository makes it relatively convenient for this to happen. So all of the collaborating tools can participate in creating this database of facts about a model or a service. So again, a methodology and a programmatic API approach to the capturing and the rendering of facts are both part of that. So I'm going to just give you a couple of examples of snippets of fact sheets from the AIF 360 website. So what you see here in the main body of this window is what you might expect to see from tooling generating automatically facts. So we've done a training pass. We have a certain level of accuracy. We have pointers to the data that was used for training and an identifier of a particular algorithm that was used, descriptions of the data columns, and so on. Okay, so again, this is what you might well expect to see from the tools that you use during the creation of a model. This is another portion of another one of these illustrative fact sheets on the website. And here we're talking about several things: intended domain, more details about the training data, and so on. The key thing to note here is this cannot, at least in any near-term scenario, be automatically generated. Okay, this is written by a knowledgeable human for a purpose, and I'll get to that because it's a key point. But I just want to make sure right off the bat you're aware of the fact that automatic tooling can provide some of what you need, but not all. Okay. So here's a summary of some of the user-centered work that we did initially. In order to get a preliminary understanding of the difficulties of creating this kind of documentation, we engaged a number of data scientists, first in an exploratory interview to talk about how they documented AI and what they found difficult as either producers or consumers of current documentation. But then we also went through 2 rounds of having them actually try to document a model or service that they had recently created. And what we saw is listed here. So all of them, with one exception, the one exception was a very senior data scientist with something like 20 years of experience who had a well-formed process of their own, and they did not feel they needed any additional help. Certainly reasonable. But everyone else thought that the idea of fact sheets, especially the automatic portion of fact sheets, was highly valuable. Okay. In part, that's because they realized, and we have seen since, that while facts are easily produced in the moment in some cases, they're very quickly forgotten in most cases. And as an example of that, I'll simply point to one fact sheet that we developed internally within our own team, where it took 2 days of forensic research to dig out the feature transformations on a very small training data set. It was something on the order of 20 columns and 1,000 rows. But it took us 2 days of working with the developer to actually reconstruct how they had created the features from the original data set. So if you don't capture a fact when something happens in the moment, it's likely gone, and your documentation will suffer as a result. Another concern that some people expressed is that facts may actually reveal more than they want to be known. Now, this is certainly true with respect to, say, for example, a model catalog, where external consumers might not be allowed to have access to all of the details of how a model was produced. They'll want to know about its overall accuracy and performance and so on. But certain details may be considered proprietary. Inside a development organization, it may also not be the case that everyone has access to all things. And so, of course, a fact sheet can't simply be the all facts for all people. Okay. More subtly, fact producers would express uncertainty about what their consumers' needs might actually be. And that's hardly surprising. I mean, again, think about a model catalog where a model could be used in a number of contexts by a number of people at various levels of skill. It's very hard to know what they would all need. Okay. And because of all of these things, the general sense was fact sheets are just, they're hard to create. And face it, nobody likes to document, right? It doesn't matter whether it's AI or procedural software of a normal sort. No one wants to write documentation, but documentation is often required for lots of reasons. So we need to do everything we can to make it possible to create high quality fact sheets, which takes us over to the recommendations. As I mentioned, we need to support automatic fact collection where that is possible. That is where the tools actually produce useful facts that can be captured. But we also need to support what I'll call in the moment manual fact collection. So if I am describing some aspect of a data transformation that isn't captured by the tool, I want to simply in that time note it and have it be saved as part of the collection of facts about the model. It won't do to come back tomorrow or the next day or when I'm trying to finalize the documentation. I need to capture the fact right now. Okay. For those facts that are authored, if you will, by a human, it's also not obvious in many cases what constitutes a good fact. And we've done some research in this, but basically what it comes down to is through various examples of quality facts by mechanisms for assessing fact quality and through what I'll call elicitation mechanisms, which is to say ways of perhaps, here's an example. Bias can be a very subtle aspect. I mean, algorithmically, yes, you can run the bias metrics against your data or the model output and so on, and you can gain certain insights. But depending on how you embed a model in a larger system, bias can take very interesting and subtle forms that were unanticipated. So taking someone through the process of reasoning about bias and fairness is something that an elicitation mechanism could do. Think of it as a wizard, for example, that would take you through a series of steps. And the reason for this is that in the absence of it, people will just generally say, oh, it's not applicable, when in fact, considerations of bias may be quite applicable, but they need help in thinking it through. Another thing that would be very useful is anything that promotes consistency through, in this case, for example, a set of standard fact types. So for models of a certain type, there may well be accuracy metrics of a certain type, and giving people easy access to creating consistent information about a model promotes also the ability to compare models. If you have a choice of models, comparison is key. And if you're going to compare meaningfully, you want to be able to compare, as we say, apples to apples and not apples to oranges. Okay. Lastly, it became very clear to us that fact sheets take many forms. And consumers of facts have various levels of skills and lots of different needs and so on, depending on their job role. So we need to support a mechanism for taking any given collection of facts and showing them in different ways, depending on how they're being used. So 2 key takeaways. You may have guessed by now that we're pretty convinced that one size will not fit all needs, and that tooling, I've mentioned the API, but also a series of collaborating tools that would generate facts and consumer facts and so on. Tooling will be essential for this to actually roll out in a scalable way. Which takes us to fact sheet templates. The notion here is pretty simple. In the middle, we have a collection of, let's call them model facts about the underlying data, the metrics during development, testing, information about the lineage of the data or versions of the model from which this model is derived, the sort of qualitative information such as model purpose and so on that I described before. So all these facts are collected, and you can think of them as sitting in this repository. A fact sheet template can be thought of as basically defining a query against that set of model facts, where it basically what you're saying is, for this model, give me all facts of this type. And then, having retrieved all the facts defined by the template, a fact sheet can then be rendered. Okay. Another way of thinking about it is shown at the bottom. You can think of the fact sheet template as questions. The answers to questions all reside within the model fact repository, and a fact sheet is the questions and their answers. Okay. And again, returning to the notion that facts can be rendered in different ways. Some of the ways that we've already created examples of in the AI Fact Sheet 360 website is facts can be shown within, say, a Jupyter notebook for a data scientist. Obviously, a web tool can provide summaries and views. PDF reports can be generated. We also show an example of rendering a fact sheet as a slide deck. It turns out that data scientists, for example, are often in the position of having to create a slide deck to present, say, to a review board, facts about their model. To the extent we can help them do that automatically, that's great. Okay. So I've mentioned the AI lifecycle, and if you're engaged in the development of AI models, this is going to be familiar to you. So in a somewhat simplified view of what goes on, you can start at the top and flow down to the bottom. But of course, in reality, there are cycles within this, and iteration and refinement and so on. But to keep things relatively straightforward, let's just treat it as if it is actually a serial process. So in the canonical case, a business owner is responsible for deciding that, say, a model or service needs to be built for some purpose within their organization. A data scientist or team of data scientists will be involved in actually creating and doing testing, initial testing of that model or service. Oop, went back too far. Let me go back. There we go. In some organizations, especially in finance, we're finding a role that you can think of as a model validator. So they take, depending on exactly the protocol involved in the organization, they will take the model and some degree of documentation and actually test it independently, sometimes even creating their own candidate models to see if they can produce the same results with, say, fewer features, which makes it less, prone to attack, and so on and so forth. After model validation, it will often go through an approval process. I mentioned IBM has an AI ethics review board, which is what we do for this approval step. A model itself is often just a part of a larger application, and there may be multiple models as well. So software developers are engaged in doing this integration. And then, of course, there's deployment and ongoing production monitoring for things to detect problems like drift or changes in the assumptions about the kind of incoming data and so on and so forth. So this is the entire process, if you will. And the key point is, along the way, each of these different people generates different kinds of facts. And again, we want a mechanism for capturing those for use in fact sheets, both at the end of the process, but within the process. So what the data scientist, say, produces by way of facts are useful for the model validator. And of course, what the model validator produces are useful for the business approver, and so on. So I've introduced you to the notion of templates and facts, but how do you actually go about creating useful fact sheets? Now, let me caution you. One way that we do not recommend, but is certainly the way that most people would want to start, is to go to a set of examples, and we provide examples, and looking through them, taking one and saying, this is good enough. Well, in many cases, it won't be good enough. Okay, so we actually encourage what we call a 7-step process, which is very user-centered for actually developing, refining, and finally deploying fact sheet templates and their associated fact sheets. Okay, so for purposes of illustration, I'm going to be talking about 2 fictional people. One is Carmen, and C for consumer, that's Carmen. And her role is model validator. So she's downstream of the data scientist, who we name Priya, P for producer, okay? And we're going to be talking about them as if they're real people, okay? The 7 steps are: get to know who those consumers are within, say, your organization. So what facts do they need to know? Then also get to know, and again, this is presented as if it's a serial flow, and like all things, there are cycles and refinement steps and so on. But again, to make it relatively straightforward, I'm giving you a sense that it's sort of top to bottom. So know your consumers, know your producers of facts, create an initial fact sheet template, have producers actually fill that in. Then, well, actually, it's 2 steps, which I'll explain. Eventually, producers will create a fact sheet. Then that fact sheet is evaluated with actual consumers. And of course, this is a major, return to an improvement cycle and so on, because you're not going to get, we never got it right the first time. I doubt very much that you will either, okay? But as you'll see, it's not that hard to do. I'm making it seem like it's a very laborious process. It really isn't, as you'll see. And then the final step is, once you've mastered this, say for one class of model or application domain, it's much easier to do it again. So you can begin to produce these templates quite rapidly for other consumers, audiences, or purposes, right? So I'm going to take you through those 7 steps. And I'm going to do it to provide sort of 2 kinds of information. So who is doing this? Okay. And what are you trying to learn? And then a series of sample questions that you might ask a consumer or producer to answer in order to get a much better sense of what a fact sheet needs to do for them. Okay. We start with consumers because fact sheets are produced to be consumed. I mean, it does no good to produce facts that no one looks at. That's a waste of time. So, who are these consumers and what do they need to know? And they're going to be distributed throughout the life cycle and beyond. Again, external regulators, especially in the financial sector, are a key consumer of facts, and so on. Okay. So who is doing this initial step? Well, it's what we call the fact sheets team, working with potential consumers. And the fact sheets team can be any, you don't need really specialized training. You need the ability to ask questions and listen carefully to answers. But, some background in interview techniques or, user-centered design or what have you is certainly useful, but it's not a requirement. Okay, but it is, the fact sheets team is simply indicating that it is a somewhat specialized role. It is different from, say, a data scientist doing their day-to-day work, for example. Okay, it may be a data scientist, but in this role, they're doing something different. They're trying to understand a process for fact creation and consumption. Okay, so this fact sheets team could be a single person working with one or more fact sheet consumers ask these sorts of questions. So in this case, Carmen, our consumer, How does she perform her role? What's she going to be asking for when she looks at a fact sheet, and how basically is the fact sheet going to help her do her job more effectively? And there are other questions as well. And all these are in the paper, which is linked to the AI fact sheets site as well. Having done that with consumers, you would do that with producers as well, because again, facts that can't be produced are no facts at all. So the fact sheet team would work with potential producers of facts, looking at such things as, what facts, in this case, does Priya wish she could record or does typically record, and so on and so forth. So getting a very good sense of where facts are coming from and how producers can produce them, will produce them, is key. Again, some of those facts will come out of the tooling they use. Some of the facts need to be written, for example, by the business owner, and so on. You then create a fact sheet template. Again, think of this as the set of questions. They're often organized in terms of topics. So there may be a section on accuracy with sub areas, a section on bias, certainly a section on data and its transformation, and so on. And then ideally, what we've found anyway, is it's very helpful, again, for the fact sheet team, having produced this template, to just try to fill it in themselves. They probably already knew a fair bit about what goes on in the development process within their organization. They certainly know a lot more, having interviewed the Carmens and the Priyas. So before you go back to an actual producer and take more of their time in the next step, it's good to go through, if you will, a trial run. Try filling this out yourself. You'll often uncover issues of the sort that can be revealed by the questions you see here. Excuse me. And then you go back to actual producers. So again, the who now is very large. It can be business owners, data scientists, validators, so on and so forth. And they would then, for a model or a service, actually attempt to create a fact sheet, okay, to fill it in. And this, you're going to find ways in which the template is insufficient, where you need to provide examples and hints and so on and so forth. And now back to the consumers. You've had the producers, create a fact sheet. And so you can go back to all the people who might be consuming facts along the life cycle or beyond, if you can, and determine, well, what's still missing, and why are missing things important, and so on. Okay. And then finally, having done this, as I said before, it's much easier to do it the next time. It's like all things in life that way. You get better at it with practice. And you're going to find, other needs, other domains, different model types, and so on. So in a fully fleshed out AI development organization with a well-defined set of templates, there's always going to be the need for more. And if you're feeling like, oh, this is way too much work, it's not, okay? Even if you talk to only one producer and one consumer per role in an organization, you'll learn a lot, and it will be very useful. It's so much better than simply trying to take an example on your own and assume it will work, or just sit in your office based on your kind of abstract understanding of what goes on in a development organization and produce a template. It's just much better to engage with actual producers and consumers. And the other point to make is, rather than try to attain perfection at each step, because you won't, it's not possible to do. So don't waste your time trying. So, move quickly and be prepared to iterate as you learn more.